Hello, welcome back to Chapter 1, Section 9, Introduction to Parent Functions. I'm doing problems 2 through 7 in the guided practice problems that are on page 69. If you're, actually, I think that's actually reversed. I think it's actually page 70 from the book and page 69 from the PDF. But they're only off by 1, so it's okay. Sorry, I just realized that I wrote it down when I was like typing this up, and I must have typed them backwards. Either way, it's okay. You can find them. This is the guided practice problems before the homework. So just like the first example, we're going to identify the parent function, and then we're going to graph it. We're going to use Desmos to graph it, and we're going to try to see if we can figure out what the transformation was. All right, so I've got this nearby, which is going to help us identify these. So number 2 starts off with g of x is going to be parentheses, x subtract 1, parentheses to the third power. All right, so the first thing I notice is I've got an exponent of 3. When I look, exponent of 3 tells me I've got the cubic family, parent function is x cubed. That's pretty straightforward. So the parent is f of x equals x cubed, and even though it did not ask, I'm including this. The family is the cubic family. So now let's switch over and look at the graph. Again, I'm using Desmos, and here's the one we got. Okay, now like I said, that looks like the cubic, which is up here for me. So the parent function is in black, and the function we're talking about, g of x, sorry, I got the hiccups. I really all of a sudden got the hiccups, sorry, is in green. So it looks like my black graph did not go up or down, so it's not a vertical transformation. It looks like it actually got pushed over from here over here. So everything looks like it got pushed to the right. So right here went here. This point at the origin went over here to this place. Right here got switched over right here. Now, if you remember in an earlier video, and maybe I should write it down again, I said that if you see parentheses, and I'll just abbreviate, that tells me I have a horizontal transformation. And if you have no parentheses, at least the x is not inside parentheses, I should have been clear about that, it is a vertical transformation. I see parentheses, so this is going to be horizontal, and it looked like from the graph that it moved to the right 1 unit. And of course, right now we're just trying to use the graph to describe what we see. All right, let's look at number 3. So I see the x to the second power. So looking back at my table, which is over there, but I think by now you're getting it. This is going to be the parent function is fx equals x squared, and the family is going to be the quadratic family. So let's look at the graph real quick. Try to hide this. I'll show the quadratic since I'm already here. I'll hide that one from previous. So this is my new one. Inside parentheses, x plus 1, and then squared. So now look what happened. My parent function is this. Let's zoom out a little bit. My parent function is this blue graph, the original one that I showed you, and the purple graph looks like it got pushed over this direction, like that way. How far did it go? Well, here's my origin at 0, 0, and it moved over here at negative 1, 0. This point right here at 1, 1 moved over here to 0, 1. And this point at negative 1, 1 went to negative 2. So I'm changing all of the x's, and it looks like it is a horizontal translation. And I just realized I said something last time, but I didn't write it. And this time it looks so it went left 1 unit. For problem number 2, I forgot to write the word translation, and if I turn that in, I will get it marked wrong, so I need to fix that. And notice parentheses, horizontal, parentheses, horizontal again. All right. Trying to grab the next paper here with the other problems. It's just not letting me separate them. I know it's a professional thing you're seeing here. I need an editor. Okay. So real quick, while I'm looking at it, no parentheses, no parentheses, no parentheses around the x. I know I've got this thing here. So I think this is going to be vertical, vertical, vertical. This one, we'll talk about that. We'll talk about that in a second, okay? All right, so number 4, I don't see any exponent. I don't see a radical, nothing like that. So I think that this is, the parent function is going to be f of x equals x. That tells me that the family is the linear family. The new covers are really awkward. So let's show that one. I'll go up here. Let's get that put away and let's see. Okay. So yeah, the green line right here is the parent. The black line is the one we're talking about, the child, so to speak. And it does look like it is linear. So we got that. But now can we describe the transformations? Well, I'll be honest with you. Describing transformations of linear functions is kind of hard because of the shape of a line, which is so cool, but there's very few distinguishing features with it. Okay, it's not like, notice that for the other ones I've been looking at, like where the vertex is of the quadratic function, or where what we call the point of inflection, where it changes direction for the cubic, that kind of stuff. I don't have anything like that. The only thing for a linear function is I've got the slope and the y-intercept. So the y-intercept, they both cross at the origin, so that stays the same. But where the green line has a slope of positive 1, right? Don't say rise or run. The vertical changes 1, the horizontal changes 1. This time, this one goes down 1 space and to the right 1 space, or you can say it goes up and to the left. So it looks like the slope of this one is -1, which makes sense because it's y equal, or g of x equals -x. But how does that tell me what the transformation is? Well, if I multiply the x by -1, just like with the points we learned last week, then I end up with a vertical reflection. And vertical reflections are over the x-axis. So if I look at my graph, if I look at this point right here, which is 2, 2, it got reflected down here to 2, -2. 5, 5 got reflected to 5, -5. Now, you're saying, but wait, wouldn't this also be 2, 2 goes over here to -2, 2? So instead of just reflecting like from here and like boom, you could also reflect like that. That probably didn't make any sense at all. This is why we try to avoid talking about transformations with lines. The answer is yes, that's actually true. Well, how do you know if you got the right answer? So you look at this. Did you see parentheses? The rule is if you see parentheses, it's horizontal. Since I didn't see parentheses, that means it's vertical. Let's talk about number 5. So I think the square root is probably going to give it away. The parent function is f of x equals square root of x. And the family is our old friend, the square root family. So now let's talk about whether or not it is a horizontal or vertical transformation. Since I'm adding to the x, that tells me it's going to be like probably a translation. If I have a negative in front of the x somewhere, that means I'm probably going to have a reflection. And if I multiply the x by some number, that means I'm probably going to have a stretch or compression. All these things are things we're going to learn about. It's not something you're going to get in one video. So if you're going, huh? It's okay. I got the idea that maybe this is going to be a translation. But is it horizontal or vertical? So what I say, the rule was if it's inside parentheses. Well, guess what? This radical symbol groups things together like parentheses do. Parentheses, like I'll show you the first page we did. Parentheses, like this one, says, hey, subtract first before you do the exponent. It's a grouping symbol. Well, there are other grouping symbols that we have, and radicals act like grouping symbols. We actually have hidden parentheses around the x plus 3. Basically, it says, before you take the square root, I want you to add x plus 3 first. That goes back to order of operations. Okay, so I think that this is going to be horizontal. The only question is, horizontal what? So again, back to Desmos. Tap that away, tap that away, tap it away. Here's my graph. All right, cool. That does look like the square root parent, which is up here, right here. They're both red. Oh, okay. Change that one to blue. Okay, so the parent is blue. So how did I go from the parent, the blue function, over here to the red function? Well, it looks like all I did was take this and push it to the left. This one right here at 1, 1 got pushed over here at -2, 1. This right here at 4, 2, the square root of 4 is 2, got pushed over here to 1, 2. And I can go through all the way. Now, maybe you might think, well, also the blue goes up to the red, but it doesn't. This point right here does not go here. It goes to the left. So, looking at the graph and trying to look for patterns that we have here so far, this looks like a horizontal translation to the left 3 spaces. And one thing we're going to talk about that's going to come up is, well, if the x's go left, that means the x's become negative, but that's plus 3. That's interesting. I'm going to put a pin in that for right now. But obviously from the graph, it did go left. So we'll take it from there. Number 6, I see an x to the second power, so my parent function is going to be x squared. That tells me that the family is going to be the quadratic family. And let's graph it and see what happens. So let's get rid of that, the ones from before. And here's the one I'm talking about. Okay, let's look at it right here. So I've got that parabola shape. I've got that parabola shape that we mentioned. So it is quadratic. Here's my quadratic parent function, which again is, I thought I had them all different colors. Don't worry about it. I'm going to go from this one here that goes to the origin to up here. Looks like I moved everything up 4 spaces. Let's zoom in and count. So this goes 1, 2, 3, 4. Yep, right there at 4. So I'm going to call this one a vertical translation up 4 units. And remember, the rule is if you don't see parentheses, it is a vertical change. I don't see any parentheses in number 6, so it looks vertical. All right, number 7, I love what Dr. Berger's doing here. He's trying to trick you. I appreciate that. I admire that, but I don't do that. I don't want to feel like I'm tricking you or anything. What do you think the most popular wrong answer is going to be here? People are going to see the square root of 2 and say, oh, it's a square root function. Before I do anything at all, let's graph it and see if I get a square root function. Here's what the square root function looks like. So it makes that curve here. What I have is this one. X subtract square root of 2. So this tells me just because you see a square root in it, that does not mean it's a square root function. If the x is under the radical, then yes, square root function. But the x is not under the radical, only the 2 is. This is just x subtract some number. Square root of 2 is constant. It's approximately 1.414. All right, we talked about square root of 2 being irrational, but I'm not going to worry about that right now. It's approximately 1.4. This is just a linear function. So the parent function is f of x equals x. The family is the linear family. And the transformation, it is a vertical, because I don't see any parentheses, translation, it's a slide, down by the square root of 2. Now again, you're probably saying, but you just said there's parentheses under the radical. That is true. But the x is not under the radical. There's no parentheses around the x. All right, we'll see you in the next video.